This geometry puzzle is absolutely beautiful. We have a large right triangle, ABC. The right angle sits at point C, and tucked perfectly inside the triangle is a green semicircle. Its flat diameter lies along the base BC, while its curved edge touches the hypotenuse AB at exactly one point. Let's call that point D. That point of tangency splits the hypotenuse into two pieces. The upper segment, AD, has length 8, and the lower segment, BD, has length 9. Our challenge is simple. Find the exact area of the green semicircle. Let's start at the top vertex, point A. Notice something interesting. From point A, two lines touch the semicircle. One goes straight down to C, the other goes down the hypotenuse to D, and both of those lines are tangent to the semicircle. This is where a famous geometry theorem comes in. If two tangents are drawn from the same external point to a circle, those tangent segments must have equal lengths. So if AD equals 8, then AC must also equal 8. That one observation changes everything. Now look at the large right triangle. We know AC equals 8, and the hypotenuse AB equals 8 plus 9, which is 17. So let's use the Pythagorean theorem to find the base BC. BC squared plus 8 squared equals 17 squared. So BC squared plus 64 equals 289. Subtract 64 from both sides, BC squared equals 225. Take the square root, and we get BC equals 15. Now we know the dimensions of the entire triangle. The only thing missing is the radius of the semicircle. Imagine the center of the semicircle is point O. Draw a line from O to the tangency point D. Because a radius drawn to a tangent point is always perpendicular to the tangent, angle ODB is 90 degrees. And suddenly, we've created a small right triangle, ODB. Now compare that small triangle to the large triangle ACB. Both triangles have a right angle, and both share the same angle at point B. That means the two triangles are similar, and once triangles are similar, their side ratios must match. In the small triangle, the vertical leg is the radius, r. The horizontal leg is BD, which equals 9. In the large triangle, the vertical leg is AC, which equals 8. The horizontal leg is BC, which equals 15. So similarity gives us r over 9 equals 8 over 15. Multiply both sides by 9. R equals 8 times 9 over 15. That equals 72 over 15. Reduce the fraction by dividing top and bottom by 3, and we get R equals 24 over 5. Now we're at the finish line. The area of a semicircle is pi times radius squared divided by 2. Substitute r equals 24 over 5. Area equals pi times the quantity 24 over 5 squared divided by 2. Squaring the fraction gives 576 over 25. So the area becomes pi times 576 over 25 divided by 2. Dividing by 2 is the same as halving the numerator. 576 divided by 2 is 288, which leaves us with 288 pi over 25. And that's the exact area of the green semicircle. If you'd like a decimal approximation, it's about 36.19 square units. If you solved it using a different method, let me know in the comments, and I'll see you in the next video.